Find the minimum number of stages for the pump. In this problem, groundwater is pumped from an aquifer into an elevated storage tank. The elevation of the groundwater table and the elevation of the water surface in the tank are provided. There is no drawdown in the groundwater table resulting from the pumping. The flow rate, actual motor speed, and minimum specific speed are also provided. In English units, the specific speed, N sub s, of a pump equals the actual motor speed, N, in revolutions per minute, times the square root of the flow rate, in gallons per minute, divided by the head added by the pump, in feet, raised to the 3/4 power. Since the problem statement provides the flow rate, motor speed, and minimum specific speed, we'll solve for the added head and identify the minimum number of stages required. Solving for the added head equals the actual speed to the 4/3 power times the flow rate to the 2/3 power divided by the specific speed to the 4/3 power. If we look at a pump curve, we recall that the total flow rate resulting from multiple pumps operating in parallel is the sum of the flow rates from each individual pump for a given head. Similarly, the total head resulting from multiple pumps operating in series is the sum of the heads from each individual pump for a given flow rate. When a single pump is fitted with multiple stages, each set of impellers, or bowls, can be thought of as separate pumps operating in series. Therefore, if the change in head, or lift, generated by the pump is a fixed quantity, then the required lift for each stage is inversely proportional to the number of stages in the well casing. Therefore, if the value of delta H is known, and the pump has 4 stages, as shown here, then for a given flow rate, Q, the total head produced by the pump is shared equally between the 4 stages. If there were only 3 stages, each individual stage would be required to add more head to the system. Same is true if there were only 2 stages, or 1 stage. From before, the equation for the specific speed of the pump, N sub s, assumes there is only 1 stage. However, for a pump with multiple stages, the specific speed is based on the head lift per stage, and increases as the number of stages increases. The question asks to find the minimum number of stages such that the specific speed is at least 1500. The minimum number of stages is a function of the total head, the minimum specific speed, the motor speed, and the flow rate. The last unknown variable is the change in head, delta H, which equals the total head of water in the tank minus the total head of water in the ground. Assuming the pressure head and velocity head are negligible in the tank and in the ground, the total head equation reduces to the change in elevation head between the 2 sources. Plugging in the given values for elevation, delta H equals 410 feet. Now we're ready to solve for the minimum number of stages. The variables on the right-hand side of the equation are plugged in, and the number of stages equals 5.18. Since the problem states 1500 is the minimum specific speed, then 5.18 is the minimum number of stages required for the well pump, and is rounded up to 6 stages. When reviewing the possible solutions, the answer is D.